the worksheet instead of you watching the PowerPoint. So I completed the first part of the worksheet, which is kind of like you plug in the time 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in for X, and it'll shoot out all the different times and heights. I'm not sure if that student had problems with orders of operations, but remember that it's exponents followed by multiplication, left to right, and then we have subtraction. So if you do that right, you get this table, this pattern, and it's also symmetrical like the way you've seen it. So number 2, the student wanted me to write all the answers down. So it describes how the height is changing over the time interval 0 to 10. So I did do it in the PowerPoint, but if you want to notice, you can see that I would say the height increases and decreases in the same way after reaching the highest point. So it increases and then decreases, kind of in the same way after it reaches this high point way up there. You can see my graph, yeah, like way up there you can see that's a high point, and then it seems to repeat. What's the height at 3 seconds and 7 seconds? So I can just go to my chart and say that it's 210 feet, and the other one is also, let me scroll down, and at 7 seconds, if I look at my chart, it's also 210 feet. Again, we noticed, obviously, they are the same height. Why did this occur? I'm not sure. Maybe because the roller coaster I would say something like the roller coaster went up and then down. So that means, of course, if it goes up, it's going to happen another time where it goes down at that same height. Locate other times when they're at the same height. Well, you should see a bunch. 1 and 9 seconds is a pair, and 2 and 8. 3 and 7 we already noticed. 4 and 6. So that's a bunch, and technically every infinite amount of points too as well. These are just the whole numbers, but all the fractions would work as well. Okay, what's the maximum height for this ride? That would be question 6. Let me scroll up there. Well, this roller coaster seemed to get up to 250 feet. What time did this occur? This occurred at 5 seconds. I found it by finding the highest point on the graph. I also noticed that there were no other pairs that went with that point. It was the highest point, then it came back down. Do you think it's a coincidence that the max height happened at 5 seconds? I would say no. That's why we designed this lesson. No, because I would say no, because it at 0 seconds and 10 seconds, the roller coaster was on the ground, and 5 seconds is the halfway point. Something like that, right? Let me zoom out a little bit. You probably can zoom in. Yeah, so I would say no, because it's at 0 seconds, at 10 seconds, the roller coaster was on the ground, 0 feet. So it makes sense that halfway between those, at 5 seconds, that's when the highest point was reached. What time interval is the height of a roller coaster increasing? You might have seen me use some notation, but we can say from 0 to 5. So definitely when 0 is less than or equal to, when the time is less than or equal to 0, oh, sorry, when 0 is less than or equal to time and less than 5, you could have said 0 to 5 as well. And then from decreasing, you could have said from 5 to 10, but you might have written it 5 is less than x, which is less than or equal to 10. You might notice I don't put the little line underneath, because some students always argue whether the roller coaster is like kind of at 5, it's like that switching point. So instead of saying less than or equal to 5, less than or equal to 5, I would just say less than, because at 5 it might be like neither increasing or decreasing. It's kind of at the level. How would you describe the shape of the graph? I did give it in it, but say like a hill or a frown, right? We talked about this word in the last one, but it definitely seems symmetrical, right? I would say that it has a high point for sure, right? A high point. And I think I want you to notice that it has a y-intercept, just like linear. But it also two x-intercepts, which we didn't spend much time on, but we will as we go. But it actually has two x-intercepts. It touched at 0 and 10, if you think about that graph, right? Okay, if you plug in 11, you get a negative feet, which makes you think below ground. So is it possible to be negative feet below ground? Maybe, right? If the roller coaster went below the ground. How about in B? Well, I would say no, because you can't have negative time, right? So when we say f of negative 2, that negative 2 is the second, so that's not really possible. And yes, this last one is possible, because there is half a second, right? Something like that. So those are the lesson for Micah or whoever wanted it, and you can watch me go over that handout.